Alrighty, good morning and welcome to the next installment of Mr. Neuberts Amazing Video Lessons, part 13 I believe it is now. So we're going to be talking about Newton's laws. You read about Newton's laws. We've taken the show outside, a little chilly this morning, but that's alright. Still got to get it filmed. Talking about Newton's laws this week, and we'll wrap it up. We got about 2 more weeks of school here, a little bit less. So today we're going to be talking about Newton's first law. You've already read about it. You should be familiar with the 3 laws. We're going to focus on the first law today and get into the second law tomorrow, and then later this week, the 3rd law. So Newton's first law: an object at rest remains at rest. An object in motion will remain in motion at a constant velocity in a straight line unless acted upon by an unbalanced force. So we got our bowling ball out here, got a baseball down here if you can see it, and my longboard. So bowling ball, everything's at rest. Okay, there goes Jim. Object at rest remains at rest unless acted upon by an unbalanced force. So the objects are at rest; they don't want to move. Okay. And it's based on what Newton called inertia. Inertia is based on the amount of mass in an object. The more mass an object has, the more inertia it has. And, inertia is the tendency of an object to resist a change in motion. These objects don't want to move. They're resisting a change in motion based on their mass. If I were to kick the bowling ball and kick the baseball, which one is going to move easier? The baseball, obviously, because it has less mass. All right, so we're going to set them free here in a second. Object at rest remain at rest. Object in motion will remain in motion. I'm going to apply an unbalanced force, and then you'll see gravity will pull it down the driveway, and there's going to be another unbalanced force out there somewhere that's going to slow that thing down. So here we go. Checking for traffic, no cars coming. There we go. Gravity's pulling it down the driveway. It's accelerating. It's bouncing. Hits the curb, hits the grass, and it slows down to a stop. Another unbalanced force, friction between the ball and the grass, slowed it down. Okay. The baseball, I don't even have to kick it to get it started because our driveway is at an angle. So as soon as I move the longboard, the baseball will start to travel. Okay. But watch what happens. There's a couple of, obviously there's going to be an unbalanced force between the ball and the driveway, but there's something else going on too. Gravity's going to take part in this and change its direction too. So remove that. It's rolling down. It's accelerating. Kind of at a constant speed now. It's flattened out, and gravity is slowing it to a stop. I'm going to hit the ball so nobody runs it over. Stop because it has less mass and therefore less inertia to overcome the friction between the ball and the ground. The bowling ball had more mass and kept rolling. It's able to overcome the friction greater because it has more mass, has more inertia. Okay? In a perfect situation, I'm not going to roll the longboard. In a perfect situation, the objects will travel in a straight line, okay, at a constant speed forever. Okay, in a perfect situation. That's what Newton realized. But we got a lot of forces here on Earth. If we get out into space, there's no air resistance because there's no air in space. There is gravity in space, but there's no air. And if you're far enough away from the planet, the effects of gravity decrease. Okay. Hopefully you watched Apollo 13. It wasn't required, but hopefully some of you guys watched Apollo 13. It's a great movie. When any of those Apollo missions were orbiting the planet, gravity is the force that's keeping it going. That's the unbalanced force keeping it going in a circle around us in its orbit at 17,500 miles an hour. There goes Reagan. If they put the pedal to the metal and get it up to 25,000 miles per hour, that's called escape velocity. And that's how fast they need to go to break free of most of Earth's gravity and be on a trajectory towards the moon or towards the Mars, wherever you want to go. So if they're on the way to Mars, or on the way to the moon rather, they're able to shut down the engines. Once they get up to 25 thou, they shut down the engines, and now Sir Isaac Newton takes over, as they said in the movie. It's able to maintain that speed at 25,000 miles an hour. There's nothing to slow it down, and pretty much going in a straight line. Okay, there is gravity in space, but they're not being tugged on in any particular direction very much because they're so far away from everything. Remember, gravity decreases with distance. So if you're out in the middle of nowhere between the Earth and Moon, or between the Earth and Mars somewhere, you're pretty much going to go in that same trajectory. Okay? So the best example of Newton's first law is a rocket traveling through space. Objects in motion will remain in motion in a straight line towards the moon at a constant velocity, maintaining that constant speed because there's no air resistance to slow it down, moving off towards the moon. Okay, so there's some examples of Newton's first law. We'll get into the second law tomorrow. Hope you enjoyed this little outdoor activity, and have a good day. See ya.